Hello everyone, we'll be presenting our project, EZPaperSearch. As most of us have experienced, paper searching can be a very time-consuming and tiring process, especially when we are looking for a paper on a very specific topic. So the goal of our project is to build an efficient and effective paper recommendation application that helps users find papers that they might be interested in. And the goal is to save time and energy spent on paper searching. So the paper recommendation application takes in title and abstract of the context paper from the user and outputs a list of related papers as recommendations. The dataset we use is the open source S2ORC dataset. This is a very large dataset covering millions of scientific papers from various fields of studies. And this dataset contains all the necessary information we needed for constructing our model. And considering the size of the dataset, only a subset of it was used for the purpose of the project. For data processing, we did data cleaning and data labeling. Firstly, we removed the data points with missing information and the non-English paper entries from the dataset. We then generated unique paper pairs from the dataset. After that, the binary labels were produced to indicate whether the pair of papers are related. And this is done by measuring the similarity of references used in these two papers. Lastly, we balanced the dataset via negative sampling. Our resulting dataset contains 1,656 data points that are split into training, validation, and testing set with 0.7, 0.2, 0.15, and 0.15 ratio. Both of our models measures the similarity of the context paper and the candidate paper in pairs and outputs a binary label indicating whether the two papers are related. Our baseline model is a TF-IDF model that evaluates how relevant a word is to a document in a collection of documents. The model first converts the abstract of the context paper and the target paper into vector representations using the TF-IDF vectorizer. Then the cosine similarity between the vector representations is calculated, and the threshold of 0.5 is applied on the cosine similarity to determine if the two papers are related. Next, my teammate will talk about our main model.
Okay, now I'm going to introduce our model. So we decided to use these Siamese deep learning networks. So we trained two identical pre-trained models and then applied average pooling to get the text embeddings. Then we concatenate these two embeddings and their difference together and fit into a binary classifier. So our model will predict whether these two papers are related or not. So this is how we trained our model. So after the training, we got some quantitative results. So we tried different pre-trained models from GPT-2 to some BERT-based models. So we found actually GPT-2's smaller version achieved the best performance with a reasonable processing time. Our baseline model has shortest processing time, but the performance is not as factory as the GPT-2. So we decided to use the GPT-2 in our project as a model choice. However, in our case, the workflow in the inference mode is quite different. So to save the inference time, we pre-compute the embeddings of all the papers in the ones and save into a database. So when we receive the input paper from the user, we're going to first check whether this paper in the database. If the answer is yes, we're going to fetch these embeddings directly from database. Otherwise, we're going to call the trained transformers to calculate the embeddings first and then insert back to the database. So after we get the input embeddings, we're going to compare it with all the embeddings in the database and for the binary classification. And our classifier will return confidence as well. That value we'll use to determine the top K recommendations. So in the last, we will discuss some lessons learned during this project. So we realized the data preparation is quite essential to a deep learning project. We are handling a huge data set. So we learned to use multiprocessing and parallel computing this technique in our data preparation procedure. It was a really learning experience for us. Also, we realized that maybe the more powerful model, pre-trained model, may not necessarily achieve the better performance. So we need to do more experiments, and the trade-off between the performance and speed is kind of critical to an application design. So that's what we learned during this project. So in the future, if time allows, so we would continue to exploring the usability of GP3 in our project. Also, we want to consider replace classify with a cosine similarity method, but that we also might need to change how we train our model. Thank you. That is our application, EZPaperSearch.